Hello, I'm pleased to welcome you at the fourth part of tutorial called Openness in Radio Access Network Design in 6G, the ORAN concept. My name is Łukasz Kułacz. I'm R&D engineer at Rimedo Labs, and I'm currently finishing my PhD degree at Poznań University of Technology. Let me switch off the camera and focus on the content of this presentation. In this part, we will look at the virtual lab where we deploy all components of the RAN intelligent controller, and we'll add the traffic steering xApp to this environment, and we will try to demonstrate some features of this type of control. So let's start with a small reminder from the previous part when we already saw this SD-RAN Helm chart. Now in more details, it is very important that this repository, which contains all recipes which allows us to build the SD-RAN, are available publicly for free in this repository. We can find here multiple components of the software-defined radio. For example, we have A1 interface, A2 interface, we have RAN simulator, we have ONOS UE NIP, which stores all information about UEs. We have also, for example, ONOS KPI MON, which is simply application which collects all KPIs. We have also, for example, ONOS MLB, so mobility load balancer, and so on. There are a lot of useful components which we can deploy on our machines. What is also important, inside this Helm chart repository, we have also a recipe for deployment of our Rimedo traffic steering xApp. This application is also publicly available. So in this repository, you can find the method how to deploy this xApp inside Kubernetes cluster using Helm. But if you are more interested in what is inside this this application, you can find also a repository with code of whole application. Okay, if we look what is inside this SD-RAN, which can be deployed using the previously shown methods, we have a RAN intelligent controller, which consists of some of these components, modules. We have also some Python and Golang SDK, which can be used to use some data to connect simply these blocks between themselves. And to this controller, we can connect using RAN simulator, which we will use in a moment. This module creates UEs, cells, and moves UEs along the predefined routes. and so on. So it mimics our real network. So this is the basic or core SD-RAN which we can deploy using SD-RAN Helm charts. And then we can deploy also our Remedo traffic steering xApp from the same Helm chart. And this application is made like this. It connects through Go SDK to this components. So the most important, I think, it connects to A1T, so A1 interface, which is responsible for receiving policies in form of JSON files. And if it matches policy type that we are using inside this type of xApp, then we can simply read and enforce such policy. Then we have a second connection. So our xApp have a connection to A2 interface through which we have information about all UEs, cells, measurement reports, so about received power. And also we can receive 5 QI value for each UE, which is already generated by RAN simulator. All messages that are exchanged using this A2 interface are already defined in this A2 service model, which is actually a plugin for this A2T component. Okay, and the last thing that we are connecting to this Openness topo, which stores information about all entities existing in this rig. So about all components or relations and so on. Okay, so to sum up, just idea how how this xApp works and how we can observe influence of this xApp on the system. First one, we can receive policies through A1 interface, and secondly, we can receive all informations about UEs like RSRP values and 5QI, and using the same interface, we can actually send a control message to directly influence on the UE association to a particular cell. Okay, and just for visualization purposes, we have also some RAN simulator API, which simply takes out some data from RAN simulator, and then using Remedo portal, so map and some simple table, we can display all things that we need to visualize the idea of this traffic steering xApp in easier way and easier in meaning of understanding this idea. So from perspective of just Remedo traffic steering xApp, we have these three components, so Openness A2T, Openness topo, and Openness A1T, which are needed simply to collect data about UEs, also about all connections and relations inside this controller, and also to collect and have access to policies. On the right side, we have also table which minimal versions of different modules or components are needed to enable or to launch our traffic steering xApp. The same data you can find on GitHub repository, and all instructions how to deploy everything in your environment. Okay, so that's ends part of introduction to virtual lab. So now we can switch to actual virtual lab and show small demonstration of how we can build SD-RAN and how we can deploy xApp inside this environment. Okay, so we prepared a couple of terminals which will be used later for different components of our system. But let's start from beginning. We can see the Kubernetes cluster, which will be used to manage all deployments that we need for our demo, and we will use Openness project SD-RAN Helm charts, which is a publicly available repository on GitHub, which consists of all Helm charts that are needed, or there are more Helm charts, but we can find here all necessary for our demonstration. So, for example, can find here A1 interface and A2 interface. There is also RAN simulator and also our traffic steering xApp, so rima.ts. Okay, and we can start from deploying all components from such Helm chart. So in this terminal, we can observe that we are inside the SD-RAN Helm chart repository, and we will use the Helm command to install SD-RAN, which is also available in this repository, with two additional things. So with RAN simulator enabled, which we will use to simulate everything in this network. And second fact, there is a model name. Inside this Helm chart repository, we can find a couple of scenarios where some cells and UIs are defined. We will use a quite simple model called 2 cells, 2 nodes to demonstrate a quite simple scenario with 2 cells and 1 UI. Okay, so by running this command, we can observe that in Kubernetes we have a couple of new pods created, which are currently starting. And from these logs, we can observe also this last line, which allows us to get inside the CLI of this Openness. So this is this thing on the left side. It is already copied here. Okay, and as all pods are running now, so this environment is ready to use, we can move to CLI to look what's inside. And for example, here we can get some information about environment. So for example, with command onos run sim get cells, we can get some information about available cells. So we have two entries with all details. So for example, position of one and first and second cell, maximum transmit power, and so on. Very similar command we can use for getting information about UIs. So here we can observe that there is only one UI, which is currently connected to such cell. And in general, through this CLI, we can get some useful data to about this environment and all devices inside. Okay, but for our demonstration, it is not very useful to show all changes in the system using terminal simply. So we prepared two additional small programs to visualize what is happening inside. So we'll leave this CLI for now, and we will install the xApp run simulator API and Rimado xApp portal. So we can observe that there are two new pods, so in the same names as I already mentioned. Okay, we can observe that xApp run sim API is currently running. So in the web browser, for example, we can move to port 8088, which is the endpoint of this API, and it simply takes the data which can be which we can get from CLI, but using HTTP request. So we have, for example, here information about cells. So we have two cells with such positions. Using second request, we have information about UIs, and we have one UI with such received power from the serving cell. We have also serving cell and position of such UI. And if we refresh, so we can get this data once again. We can observe this longitude is changed. Received power is also different. As it is still not the best way to visualize everything which is happening in the system, we have also this portal application, which is simply a web page which uses such API. So we can proceed to this one. So we have a web page with this traffic steering xApp. And here we can observe a simple map with okay, where we have two cells represented by these two markers. We have also single UI, which in this model, what is now clearly visible, is moving between these two cells, like in ping pong effect. And we have also an additional thing. So we have this green line, which connects serving cell and this UI. So we can observe to which cell this UI is currently connected. For now, CO is switching between cells just in the middle, as we have the same transmit power in both cells. Okay, so we will use it to visualize what is happening, and now we can move to traffic steering xApp. So using the same repository, so SD-RUN Helm charts, we can install Remado traffic steering xApp using such command in this last terminal. So we can just run this one. Okay, in the list of pods, we can observe there is new entry with Remado traffic steering, which is currently launching. Now we can observe it is ready to use. So we will use our map to visualize, and we can also display some logs from our xApp. So maximize this one to just observe in the meantime what is happening together with our map. So for now we can observe a cell list. So we have again two cells with a list of UIs connected to such cell, and then we have list of UIs which have some parameters, serving cell, and also received power to the neighboring cells. Okay, we have also this parameter connected to UI, which is 5QI, which indicates the traffic demand of this UI. And this is a random value generated by a simulator, and in random moments of time, it will switch between 1 and 2, which for us represents if such UI will use something like voice traffic, or with number or index 2, which will use MBB traffic, so like media traffic. We will back to this parameter later. So let's start with the basics. We'll use also some REST client just to communicate with system through A1 interface. So on this URL, we can find our Kubernetes cluster, and on this port we have A1 interface. And if we send a get query to policy types URL, we'll observe the response from the system that there is one available policy type, which is already registered by our traffic steering xApp. So this ORAN traffic steering preference in version 2. And then if we try to send again a get query, but with policy types, with selected policy type, and with policies, so we can achieve which policies are currently enforced. So such query response of this query contains empty list, so there is no policies for now, as we have a fresh environment and we didn't set any policies yet. Okay, so we can influence on this scenario just by sending first policy. So with such example, let me just copy this ID. Okay, need to update this one. Okay, so we have first policy, which will send to A1 interface with ID 1, which is indicated by its last parameter in the URL with put message. And inside this policy, we have a scope. So this policy is valid only for this UE, so only for our UE, which is now moving between cells. And this policy means that this cell, this is list of parameters which describes cell on the left side, so this one. And we indicate that we should so this UE should prefer this cell on the left. So we will look how it's working. So we can send this policy, and in response we can observe response code 201, so created. And now on the map we can observe that this UE is switching to this cell on the left, but not in the middle of this road, but with higher distance. So you can look now. So we are still connected to the left cell, and still, and just in somewhere here, we are connecting to the right cell. So is working just as policy says. So this UE prefers connection to the cell on the left. In the logs, we can observe also policy number 1. So there's also entry visible here that we are currently using this this policy. Okay, and if we send delete request with policy ID 1, we can observe that in logs there is switch back to the default behavior of this network, and this UE is switching between cells just in the middle. So there is no policy for such UE, and this is the default behavior of the association function. Yeah. Okay. So now we can send the second policy with ID 2. This time we will use the same UE as a scope of this policy and the same cell, but we will use preference avoid. So we will move that this UE should avoid connection to the cell on the left. So if we send this one, once again, we can observe response code 201. And in the logs, we have policy list, which is visible here. And in our map, can observe that now we are not switching in the middle of this map, but somewhere here. So again, it is working just as we have in policy. So this UE is avoiding connection to the cell on the left. Okay, we can now update this policy. So without deleting this one, we can send just updated version to the same ID, and scope is again the same, and cell is still on the left side, but now we will choose the preference forbid. So this UE should forbid connection to the left cell. So we can send this, and in the logs we can observe policy list with updated values. So policy ID 2 have now 4-bit reference for this cell. And it can be seen that this UE is still connected to the cell on the right, just as policy says. So it forbids connection to the cell on the left. So we can observe it also here. So there is no switching point in this middle of the site. There is also no switching point in here. We are still connected to the right side, the right cell. Okay, and now we will delete this policy, and we can move to the last one, which is slightly different. Now we can send a policy with ID 3, which have a different scope than previous policies. So now we have slice ID, which is currently not valid in RAN simulator. So this is just an indication that all UEs that we are discussing now will use the same slice. So it is not important, but just this field is required by this policy schema. And the most important value here is scope type, like quality of service indication. And in our case, if it is a 5QI value equals to 1. So it means for us that every UE which have 5QI equals to 1. So just once again, for us it is traffic type like voice traffic. So every UE with such metrics should use this preference. So in this case, we have a cell on the left with preference shall. So just to sum up, we have policy which scope of this policy is for each UE with 5QI equals to 1, and such UEs shall connect to the cell on the left. Okay, and once again, in the RAN simulator generates this 5QI in the random manner. So in the different moments of times, you can observe switching between these values. So now if we send this policy, we can observe in the logs that we have this policy available. And in this moment, UE have 5QI value equals to 1. So it is just as in policy, it is connected to the cell on the left with policy or with preference shall. So it will be still, so in every point of time, it should be connected to the cell on the left. Now it is switched to value 5QI2. So it is switching between cells in the middle. Why? Because we don't have any policy applied or enforced now for UEs with 5QI equals to 2. So only 5QI equals to 1 will be switching or using this policy. So we can wait a little to observe the situation. We have still 5QI equals to 2, so it is default behavior of this association function. So we can observe it will switch in the middle. Yeah, okay. Okay, and in this moment we can observe this UE switched association to the cell on the left, just because we had this 5QI equals to 1. As it is a random number, we can observe that during a small talk, it switches again to 5QI2 and again to 5QI1. And for now, as we are using still this policy, which is visible on the left, we can observe this still connected to the cell on the left. So we are using this one. Okay, and now if we delete this policy with ID 3, in the logs we can observe there is no policies. So there is no list of policies, and this UE is switching between cells in the middle, so just default behavior. So this traffic steering don't have any policy to enforce now. Okay. And just to sum up what we can, what we showed in this demonstration, we can deploy all components of SD-RAN together with this RAN simulator using a public repository called SD-RAN Helm charts. Then our traffic steering xApp can be also deployed with the same public repository. And then if we want to influence on the behavior of the cells, UEs to cells association, we need to send some policies to A1 interface endpoint, which is already deployed using this SD-RAN Helm chart. Okay, and I would like to thank you for listening and watching this tutorial. Thank you very much, and goodbye.